Good morning, ladies and gentlemen. My name is Tawanda. I'm a student here at Automation Works Training Facility. And today I'll be presenting you with my design project for term 2, where we students dove deeper into the field of electricity and discovered coding through Arduino. The great Benjamin Franklin once said, by failing to plan, you're planning for failure. I connected this quote with the importance of time management. Not being good at time management myself, I asked myself, what are the elements that prevented me from managing my time efficiently? And the first thing that came to my mind was when JC, our personal professional development facilitator, told me in the first term here at Automation Works that even having your cell phone near you when studying already decreases your focus. Although this was true for me, I had already become too dependent on my cell phone for time management purposes, as it worked as my timer, clock, and also alarm. And after knowing this motivated me to design a device that will solve this issue. My problem statement is to design an Arduino controlled device that will limit the reliance on smartphone use in work and educational settings. The first step to solving a problem is to know what the cause of the problem is. What is the cause? What leads to smartphone overusage? The first point I have there is dopamine. Our body or our brain releases the chemical called dopamine, which is a feel-good chemical. And each time we use our phone, this chemical gets released. Our brain begins to associate this feel-good chemical with using our phones. And over time, your brain begins to crave this feel-good chemical and leading you to use your phone more frequently. And secondly, the fear of missing out. You might be afraid to miss out on the latest trends on social media or the latest news, which will lead to you using your phone more. Experts recommend that to limit this overusage at work, management can implement more stricter policies on cell phone use, and people can also, if you know you overuse your cell phone, you can make a schedule to show yourself when you can allow yourself to check your phone for notifications. And while studying, physical separation from your phone is recommended for students, like putting your phone in another room or turning off your notifications completely. But although these recommendations exist, research still shows that on average about 1 hour of work time is wasted by workers, and students double that at about 2 hours of time wasted doing unessential activities on their smartphones, which gave me an extra boost to continue with my project to solve this problem. And this is my final design. Now, I will first demonstrate how it works, and then I will show you how we came from nothing to this. So I call my device the timekeeper. And this is what it looks like. So in front here we have touch buttons, which you use to set the time. So these are intervals of 1 minute, 5 minutes, and 10 minutes, 30 minutes, and 60 minutes. So if I press the 1 minute button and I press start, the display screen will display the 1 minute. It will display 1 minute has been set, and then start counting down from 60 seconds to 0. And once the countdown is complete, this little robotic arm will slap on this cube, but it's not supposed to be a cube. It's supposed to be those little ring bells that hotels use. So it will make the sound like ting, ting, ting once the timer is run out. So if I press, let's say I want to set the timer for 6 minutes. No, there isn't an interval for 6 minutes. I just press the interval for 5 minutes and 1 minute, and then it will set the timer to 6 minutes. And I can play around with the different intervals to set different times. And here at the side, I have a button that starts recording the time. Like if I press this button and I just wanted to see maybe how long does it take for me to practice my presentation, then I just press this button and it starts recording and displaying the time in minutes or seconds. And if I press it again, it stops. And then I can lock in that value. And then when I practice another presentation, that second time will get, if I want to calculate the average, so that second time will be added to the first, and the average will be calculated, and I can get access to the average by pressing the button here. So then I will see on average how long does it take for me to complete my speech. If I practice it maybe 3 times, the average of those 3 times will be calculated, and I can see that by pressing this button. And this is the reset button. Let's say I pressed, I wanted to set the timer for 30 minutes, and now I set it for 20 minutes. I can just reset. And also, if I started recording my time by accident, I can also press this button and reset the whole operation. And here's the on and off switch button, but it's not functional yet. So the power comes from the USB cable, which gets connected to the laptop. And I will demonstrate to you now. I'm just going to set the timer for 1 minute, which is the lowest I can go. So I've pressed the button for 1 minute, and then the start button. And you won't be able to see, but it's the seconds have already started counting down. No. Okay. Yep. I accidentally pressed it 2 times, so it started counting for 2 minutes instead of 1. So as the robotic arm starts slapping the bell, there's also a beep sound that will be generated by the electronic buzzer that is inside the cube. So it will be in sync with the arm. As the arm slaps, you will hear the beeping sound as well. So this timer works good because you won't only hear the sound when a certain time is run out, but you also see the little arm. So if you have your phone in another room, let's say you're focused on your work, and the alarm goes. Yeah. So I've programmed it to slap the bell 5 times and also beep 5 times, but I can change it at any time with the code. Yeah. Okay, so now I will show you the process of how I came to my final product. So my first step was some hand sketches, just to get a feel of what the design's form was going to look like, and also the measurements. And then I sketched the container box in Fusion 360, which is the which is the software platform where we sketch 3D models. So my measurements stayed the same as with my hand sketches. And then I started fitting in the touch buttons to see how they will align. So the touch buttons operate at a voltage of between 2.7 and 6 volts, and they get 5 volts from the Arduino inside. And then I started fitting in the push buttons. These are no lock push buttons, which mean if you press them, they don't stay locked inside. No, I forgot to switch it off. Okay. Yeah. So these buttons act as a signal instead of an on and off switch. So I can even program the code to count how many times the button has been pressed. And next up, I started fitting in where my LCD screen is gonna be placed at. And as you can see, this is how I determined where it's gonna be in the screw holes. And with the LCD screen came the adapter. So the adapter allowed me to, instead of using all those 16 pins, so instead of using all these 16 pins and to wire all these 16 pins on the LCD, I could just use the adapter to make a 4-pin connection. So I only used 4 wires instead of now making 16. And this is what was after I designed the robotic arm, and I just put the micro servo in there just to see how it will fit in. And this is the micro servo. So this is what lifts up the robotic arm, and it can lift up to 1.5 kilograms when it is supplied with 6 volts, but it gets 5 volts from the Arduino inside. And it is plastic gears which allow the arm to spin. And this is where I decided how everything is going to come together, like where the arm is going to fit on this platform. And the micro servo, as you can see here, it is little screw holes that allows you to attach it to the bottom of a platform. And this is how I attached it with screws so that it stays secured when the arm moves. Next up, I made a space for my electronic buzzer, which generates the beeping sound as the hand is slamming down. And the last electronic component is the Arduino Uno itself, or in other words, the brains of the whole operation. So I attached a sensor shield to the Arduino to make wiring easier, and also to allow me to make more wire connections. Because now, instead of using the limited or less Arduino or less pins, outputs and inputs that the Arduino Uno has, I could make more connection with the sensor shield attached to the Arduino. And here's just a rough diagram that shows how it is wired. These are only pins. This diagram only shows the signal pins going to the Arduino. And this is what the device can do, as I've explained the intervals, and it can calculate the average time spent on certain activities as you record. And this is the code, or just parts of the code, to make the servo spin and the electronic buzzer beep, it waits until the countdown, there where it says 4I0 when the minutes hit 0, and then it activates the sequence. And this is the part of the code that compiles the signals given by the touch buttons. So when you press the touch button, this determines the time you've set, and then it displays on the LCD time set for in the minutes. And I had to use an extra library in the Arduino IDE for the LCD screen. So before I added the library, I kept getting errors because it won't allow you to continue to compile the code unless you added the library. The library is on top there where it says include LCD. So if you don't add that, you don't compile and the code won't work. And this is the part that shows when the timer is running. So I just said so I just told the code to display time set for, and to display not only the minutes but also the seconds counting down. So the technical difficulties I had was after I printed the robotic arm, when I tried to spin it, it kept hitting against the back part, the part that I've cut out here, so the arm couldn't spin fully. So I had to cut out that part. So this is the before and after. And also, I didn't compensate enough space for the LCD to go in, so I also had to cut out some pieces there. And the other issue I had was with the servo motors I used. The first two made a lot of noise before the sequence even began, so which debunked the whole purpose of having a timer if the timer keeps making noise before the time is even run out. This is a video when I first tested the device, but I can't play it now. I'm just going to skip it because I've already demonstrated to you. Oh, that's playing. And this is my bill of materials, which shows how much the project actually cost me. So if I bought everything that I used, it would have cost me about 630 Rand, but luckily I was able to discover most of my materials here at Automation Works, so I didn't have to buy most of them. But the ones I did buy cost me 384 Rand. That is including the 3D prints as well. So for future improvements, I actually got an idea from one of my classmates, Raven, to add a locking mechanism here at the back. So I can add a hatch that would open, so you can put your phone inside and it won't open until the timer runs out. So I think that would be a good idea for those strict parents that want to control everything.
Normal parents.
And the other improvement I want to make is to add an actual digital clock here that will display the actual time, so that you don't have to, now if you want to find out what time it is, you don't have to use an external clock. So my project research I discovered what other type of timers are out there, and I discovered there are mainly two types of timers: digital and analog timers. Digital timers are mostly used in industrial automation, and things like kitchen timers and sports timers is the one displayed here at the bottom. And analog timers are mostly used in security, advertising board, and agricultural irrigation. But I couldn't find a timer that is specifically for helping people to focus more on studies or work. So that's where my design comes in. And this is my activity log, which shows where I spent most of my time on during the term. So most of my time was spent on the design project with 41%. And the other two big chunks are the theory and the tutorial project, where we learned how to code the line following car that you see there. And this is my poster. And I would like to give my thanks to Vainant for giving me the opportunity to be able to do this course, and JC. Tani Almari said yesterday that JC turned us from boys to men. But how JC changed me is my whole perception of how I approach my problems that I face has changed. And during this term, I asked myself, why am I now so different? What has caused me to not, I almost want to say not care, but it felt like the things that used to give me stress and worry all went away, but they didn't actually go away. It was just that my perception of how I handled them changed. And that was mostly thanks to JC, who gave us lessons on how we should approach our problems. Like if we don't understand work, or if the work gets too much for us, or if we don't know where to begin. And next, I would like to thank Tani Almari. Tani Almari always sends us motivational quotes every morning on the WhatsApp group. So it's those little things that actually make a big difference in my day, and also in the day of the others that also see those quotes. And next, I would like to thank Nicholas for teaching me most of the knowledge I now know about electricity. Without him, I would have probably burned out a lot of electronics. And lastly, I would like to thank Mr. Hoppis and also Michaela, that taught us how to deliver professional presentations in a professional way. Thank you for listening. If you have any questions, feel free to ask.